to Focus. My name is Beatriz Cruz Pajares, and today's show is about an off-road car, which was a project from University of Miami, School of Engineering. And here we are with the students that were the responsible to make a reality this project. Their names, Chris Rose, Jorge Blanco, and Oscar Munoz. And here we are at Jorge Blanco's house, at his garage, in which he transformed in a workshop to make this car a reality. Okay, they designed and assembled the car. The car was called MiniBaja. And Chris, can you tell us more about this project?
This car was designed for a mechanical engineering design project MEN 342 with Dr. Huang for the East Conference of the MiniBaja competition, which was held at McGill University in Montreal, Canada. We designed the car around the 8 horsepower Briggs & Stratton motor. We have a rear wheel drive with hydraulic disc brakes and rack and pinion steering with front independent suspension. The car had to be as light as possible, so we chose aluminum square tubing for the frame. It had to float, and we used fiberglass with polyurethane foam as buoys to keep it off the ground. The car is supposed to handle rough terrain and deep water conditions. It propels itself through the water using the rear wheels. And the suspension enables it to handle the bumps of rough terrain.
And this car was made for your own initiative?
Yes, pretty much so. I'm not getting any credit for it since I wasn't a member of the class, the design class. I participated in the course last year. The car failed last year because the students just weren't interested, you know. To go through a project like this, you really have to want the project to succeed. It's demanding, it requires a lot of work, a lot of time. You have to make a lot of sacrifices. And if the students aren't willing to make that sacrifices, the project is doomed. This year, I decided to try again with the students that were registered for the course. And we have succeeded with a lot of help.
Okay.
This is a milling machine. Its purpose is to mill out slots and holes and drill very accurately. It's a very accurate machine.
So this machine is for what?
This machine is a lathe. It's used for turning down circular stuff like shafts and discs. We used it to make the hubs for the front wheel, also the rear axle, as well as other shafts that we use on the car. It was used to make the front suspension as well.
Jorge, could you tell us who sponsored the vehicle?
Well, the vehicle was sponsored in part by the University of Miami, and but mostly it was the members of the group that put up the money to build the car.
Who were them?
It was me, Chris, and some friends of ours from the class.
And which one was the main purpose of this project?
Well, the project gave us credit for the class, but mostly it was a matter of personal satisfaction because it took much more effort than was necessary for the class.
And I understand that you went up to Canada, up to the competition?
Yes, that's right. And we didn't do very well, but we got there.
Hello, I'm Lucila Morales, and my guests today are the students who were involved in the project of the MiniBaja. This is the first project that ever made it to the second day of the competition in Montreal, and the second project ever fulfilled at the University of Miami. I know, Jorge, that it must have taken a lot of time, a lot of work to finish this car. How long did it take you guys to do this work?
Well, we were working on it for about 3 months from the beginning of the design stage to the completion, working mostly on weekends and at night. So I'd say it took about 2,000 man-hours of labor to assemble a car and design it.
Didn't you have a hard time having other courses at the same time that you were doing this project?
Yeah, it was a very hard time. In fact, I started the semester taking 5 courses, and I had to end up dropping 1 and taking incompletes in another 2. So yeah, it does interfere with your schoolwork.
I know that to enter in the competition, you were supposed only to design the drive system.
No, that's incorrect. We had to design the entire vehicle from the ground up. The only thing we didn't have to design was the engine, which we got from Briggs & Stratton. See, all the competitors have the same engine, 8 horsepower Briggs & Stratton, to make it uniform.
Did they send that engine for free to you?
No, the engine comes with the entry fee of some $250, I think.
And everyone has the same engine?
All the same.
And Chris, why don't you explain to me, how do you do for the designing of the steering system, and what tools do you have in order to do that?
To design the steering system, we used the Hewlett-Packard microcomputer, the HP85. The geometry of the system was first laid out on paper, then the information fed into the computer. The computer simulated the conditions which the steering system would be used in during the actual running of the course. Then it gave us an optimum design for the car.
And how did you guys find out about this competition? Who told you about it?
Well, I first learned about it from one of the students who was participating in the competition the first time the car went up. And he was telling me about it. It was a difficult project, took a lot of time. He had to make a lot of sacrifices. He suffered in his other courses. But it seemed like a pretty interesting project to me and a challenge. So the first opportunity I had, I took it.
Is the University of Miami involved in some other kind of competition besides the MiniBaja competition?
Well, there's one other competition that I know of, which the engineering school is involved with, and that's a rowboat competition in which the civil engineering department makes a canoe out of concrete, and they race it against other schools around the U.S.
And tell me, what are the different categories in the competition held at Montreal?
Well, during the race, we were judged on several events. First of all, there was the inspection of the cars. That took place on the first day of competition, where the overall design, the consumer appeal, the safety requirements, and the ease of entry and exit for the driver were judged. Then on the next day, we had the road events. First of all, there was a hill climb event in which the car had to go as fast as it could up a steep incline, and then make it as far as it could up an even steeper incline. Next was the land maneuverability, in which the car had to show what it could do, how it would perform under rough terrain.
And you did some demonstration for us before that we have in videotape, and we're going to look at those clips now to see how you did in the motocross track in Homestead and at the sea.
What enables the car to float is the sealed hull, the fiberglass floats on the side, and to some extent the tires help as well. The foam flotation allows the car to fill with water without sinking. The car does a maximum of about 3 miles an hour in the water, so it's best to tow it if you're going very far. The car boarded a little water while we were towing it, and the transmission got wet, so we had to push it out of the water. And now we're pumping out the water that we got.
And here we are in Flagler Monument Island to see the demonstration of this MiniBaja car. Let's see it. Now, Jorge, are you ready for your performance?
Yeah, we had the transmission a little wet and we dried it off, so we're ready to go.
Okay. We're glad to see you.
The car enters the water pretty much like any amphibious vehicle. It propels itself by the rear wheels using the threads on the tires as paddles or scoops. Steering in the water is accomplished by the driver shifting his body weight in the direction he wants to turn. This causes the inner wheel to lose traction. If the shore is not shallow enough for the rear wheels to grip into the sand while the car is still in the water, he will have to exit sideways. Otherwise, the car can drive right up onto the sand. Here we see he makes it pretty well.
And here we are in the same beach. We found a mechanical engineer. We want to ask him, because we are so curious, what does he think about the car?
Well, I have to say that just to see him in the water, this body of water, it just takes enough to know that the engineering in the car or the Land Rover, however they want to classify it, has to be made by very particularly, like I just told the young man, by hand. In other words, it's been made by thinking about it and drawing it and putting everything straight out on the boards and the line and very carefully, you know. So as far as the engineering is concerned, I'm sure that it's definitely doing very well. And it's surprising to see, you know, a bunch of young people really behind a project like this, where really it takes a lot of thinking and a lot of drawing and a lot of nights of planning. Just the simple fact of getting across, like I said, a body of water takes a little courage. So I just feel that you're on the right track, you know, and I wish them a lot of luck. I understand they're engineers or proud to be engineers. And listen, if this is one of the beginning of their projects in their young career, I think they, you know, there's quite a few more things there.
Down the track.
Down the track, right.
Okay, thank you.
We're going to see how the car performs on rough terrain at the RPMC motocross track in Hampstead.
This track closely resembles the course we encountered at the competition in Montreal, except for the deep water. The suspension is a simple dual control arm type with zero caster and steering angle, which makes the steering very sensitive, and it tends to slip away from you during the rough terrain. Wow, look at that jump. The large rear tires act as shock absorbers during rough riding. The power is transmitted to the rear wheels via a chain drive coupled to the engine by a continuously variable transmission, something like an automatic transmission, which works very well as long as the belt is dry. We had some problems with the transmission when the belt got wet during the water testing. On a smooth, dry, level pavement, the car can reach speeds up to 35 miles an hour. But here, because of the mud and the short distance in between the corners and the hills, top speed on this course will probably be about 20 miles per hour. As you can see, the chassis is very strong. It was constructed out of lightweight aluminum tubing in a configuration designed to withstand the dynamic loads encountered in this type of situation. So this is the end of our performance at the motocross track.
Well, that was a great performance, and now that we have
Thank
seen
you.
this, I'd like to know what kind of support, Jorge, does the university give to bachelor students like you?
Well, this year they didn't give us too much support because last year the school had spent quite a bit of money on the project and the projects had failed, so they kind of lost faith in the students that were involved in the project. Fortunately, we came through, but that was not always the case before.
Do you think that you were well coached in order to compete to this? To this competition against other universities?
No, we could have used quite a bit more information about what to expect. We didn't know that the track was as rough as it was, or just basic things like that you needed far more ground clearance than we had, or a longer wheelbase, which is something that the people in charge of this program could have told us easily since they had seen the competition before.
Do you think that the university will be able to send somebody else, some other student with the same car, or are you keeping the car for you?
No, we're gonna make a different car for next year. We're gonna try an all new design, possibly do a fiberglass body this time. Try emphasize the water aspects of it, because that seemed to be what was the winning combination there, to have good water maneuverability at the risk of some land maneuverability.
So you are not thinking of really improving this car, just making another car?
Well, to some extent, we're just changing the weights of the thing. We're emphasizing water propulsion more this time than land propulsion. Also, we need some more suspension travel and stuff in the rear, because this one was just a little too bouncy.
And Chris, did you think that are you about to graduate or something like that? Do you have a long way to go?
No, right now George and I are working on another project. At the end of that, we'll both receive our bachelor's degrees.
Which will be?
Well, we intend to finish the project by the end of next semester.
So probably on Christmas you will be engineers?
By Christmas, hopefully.
And being a graduate student, do you think that you will be able to enter in this kind of competition, or do you have to be a bachelor?
Well,
Students of...
I haven't heard anything about that, but Chris unfortunately will be leaving us for next semester. I'll be the only one that's going to stay behind of the original group. So hopefully we'll be getting some undergraduates involved in the project, and we can count on some support out of them. But as to whether graduate students can or cannot compete, I have no idea. I really haven't heard anything.
Chris, how much will a student have to invest in order to go to this type of competition, in the building of the car and also in going to Montreal? How much did you spend, guys?
Well, I would estimate the total cost of the car at about $2,500. And as far as the trip to Montreal and back, plus our accommodations in Montreal at McGill University, that came up to about $1,500, $1,600. So all in all, we're looking at $4,100.
Do you have to take somebody else with you besides you two guys?
Other members of the team, of the original team, were invited. Two other guys who were registered for the course came along with us. Also, we were supposed to have a faculty advisor along with us. Our faculty advisor wasn't able to make it to the race.
I know during the demonstration of the car, I realized that somebody else was involved in this project, some student, some Oscar Munoz. How did he get involved in this project if he wasn't even a student of UM?
Well, Oscar is a friend of mine that he studies in FIU, and he's interested in this sort of thing. He's very helpful, so he was good enough to give us some time and some help. That's all it was.
And why do you think that the previous projects failed?
Well, I think I can best answer that. I was involved with the project last year. It failed mainly because of a lack of student support. The students took the course, they were interested in designing and building a car. But when it actually got down to putting time into the work, they all decided that they had better things to do. And because of a lack of manpower, we were unable to complete the car. But this year, I got involved with the group, and together with the group for this year, we made it to the competition.
And now that you have all this information and the experience of going to this competition, don't you think that maybe you should give part of the pictures and videos to the mechanical department so the future students who want to get involved in this type of project can have some information and know better about it?
Yeah, certainly. That's what we plan to do. That's what all the groups before us should have done, so that we would have been a little better prepared. I think it's very helpful to have some information as to the course and stuff like this, which is stuff that we didn't have at all.
Because the previous student, they didn't leave anything for you.
No, they left no written records at all, to my knowledge.
Well, we must know that the only way that mechanical engineering is good is as long as their students are good. And the only way to measure this is through competition. Not the only way, but one of the ways to measure it is through competitions. And right now we're going to see a clip of the competition at Montreal that you brought for us.
This is the beginning of the endurance race. All of the cars started off in the water alongside a bank and then raced towards the other side of the water. Here is where we had our problems. The engine mounts failed through fatigue, vibration from the engine. We had to pull the car out of the mud and then try to see what we could do, if possibly get it back into the race. But the vibration from the engine with the loose engine mounts also knocked the transmission out. So at that point it was all over for us.
Yeah, that's us trying to fix it there, but there was nothing really we could do about it. We didn't know it was the engine mounts at that point. We thought it was just the transmission. And even so, we gave up because there was no way to put the transmission back together in time to make a serious effort for the race.
Well, that was a very interesting competition, and I'd like to know, guys, what are you planning for the future?
Well, I'm going to be getting my master's degree at the University of Miami, and I think Chris is planning to do the same, except he's not going to be staying here.
Where are you going, Chris?
Well, I have applied to several schools and I'm awaiting favorable results from them. I plan to do my master's in computer-aided design, computer-aided manufacturing, as well as computer-controlled machines, using the computer to increase productivity and efficiency.
Well, thanks a lot. It has been very nice having you with us, and I wish you a lot of success in your future. And this is the end of our show. I'm Lucila Morales. Don't miss our next surprise show, and enjoy yourself.
No, güey, me puso una piedra, tú. Ahí, claro. Espera, una más plana.
No pesa mucho ahora.
Joder, que saca esto de aquí, ve.
No, le damos mucho peso. What? The lake. What about it?
That's the way. Wait to see George driving. You're gonna really laugh. Hey George, you got the screwdriver in there? George. Stay close to us. George, you got a screwdriver in there? Got it. Screwdriver in there?
No. No, man.
Don't worry, just get in here. Hold on, let's get it out. You got it. Get out. Okay, come on in position. Franklin, come on. George, don't floor it. Ready, go? Go for it. Go for it.
Get up the sail!
Yeah, get out there.
Si tiene que poner un pedazo para que... Ajá.
Como una chapa para que...
Por los dos lados. Oye, ¿verdad que sí? Porque si no lo hubieras puesto. Ajá.
That was a good idea too.
Yeah.
Try to come in sideways. If you're going to avoid using the stick. Wait.
Okay, get on the track.
This is the track. This is the train track.
You know, you may be better with
Yeah, that's true. He's got... I'm not sure.
All six.
All six. I think four.
All six.
He's got less pressure per tire, too, though.
I know, that's what I'm saying. I don't know if it's going to help him or not.
Forget the tires in the back tire.
They pulled turned out when they pulled the chain back, I watched them go, when they pulled the chain back. I think I'm watching the side.
Don't fight over it.
Some people get
Why is it going on? I see George. Yeah? Where? No, it's not. Yeah, it is. No, it's not. Yeah, it is. It's a green one.
That's the car that came out first, yeah.
taking over though.
Amarillo?
No sé. last one that's in first. Este se hunde pa' carajo. Oh, he made it.